Hi students, we're going to go ahead and review for the final exam with some sample questions from the College Algebra course. Question number 1 on your study guide talks about a price reduction of a boat. You will remember the formula that we had used when encountering that type of question early in the semester. Basically, if you think about a full price as being 100%, you can subtract the amount of the reduction. So 100 minus 9 means basically you're paying 91% of the price, and that's going to be that new selling price. Well, the new selling price in this problem was $24,570. And so I have 0.91x, moving that decimal 2 places to the left, and I divide by 0.91. And when we divide by 0.91, we will end up with x equals 27,000. Now that is the original price of the boat. Now the second question in the study guide asks you to find the center and radius of a circle. So if you'll recall the circle formula that we had learned. Now notice where there's a positive 8, excuse me, there's a negative h there. HK is the center. So you will need a sign change. The center is actually the opposite of that x value and the opposite of that y value. The radius would equal to the square root of 49 because this is actually r squared. And the square root of 49 would be 7. Here's another circle problem. Again, when choosing the center is the opposite of that x value and the opposite of that y value. So both of those negatives would turn to positives. The radius would be the square root of the given number 16, which is 4. This will help us be able to graph. So I will go to 6, 2, and center my eyes there. That is the center point. Then once I determine the center, I will count out 4 spaces, 1, 2, 3, 4, in both directions. And I will even go up 1, 2, 3, 4, and down 1, 2, 3, 4. And of course my circle will be a little lopsided because I'm drawing it free-handed, but there's a rough idea of where your circle is. And you will also need to state the domain, which would be all of the x values, and the range, which would be all of the y values. Now for the domain, use the x-axis like a measuring stick. Notice that on the left of the circle, the farthest left value is a 2 on the x-axis. The farthest right-hand value is a 10. So we will say the domain is 2, 10. Using brackets shows that there are points on those values. Then use the y-axis as a measuring stick to measure the height of this circle. The lowest point of the circle corresponds to -2. And then the highest point of this circle will correspond to 6. So my range would be -2, 6. Now on this question, we are given a graph, and it is a parabola, but don't be fooled. A parabola is infinite. So remember that as it goes upward, it will continue to go outward as well. So when stating the domain, don't be fooled to think it's only on the negative side of the x-axis. It will eventually cross this y-axis and go into the positive values. So the domain would be -infinity to +infinity, and those are all the x values. The range is going to be the y values. Now if you use the y-axis as a measuring stick, there is a lowest point down here that corresponds to -2. However, there is no highest point on this parabola, so I will say that continues on to infinity. Now, when finding the domain of a fraction, a rational function, we need to make sure that we use the restricted values. The restricted values are the numbers that cause us to have a zero denominator. Because remember, the rule is you should never have a zero denominator in a fraction. So the way I do it is I just look at the denominator. You can disregard the numerator for this process and set that equal to 0. If you notice, that's the difference of two squares, and it factors. Take each factor and set that equal to 0 to find these restricted numbers. So I have a restricted number of -1, and I'm going to have a restricted number of +1. Think about the x-axis, because remember, the domain is the x-axis. The x-axis is horizontal, and in the middle you have 0, and you have your positive values, and you have your negative values over on the left. Well, we want to restrict and not use the 1 and the -1. That means every other number on the x-axis may be used for this domain. That creates 3 intervals. So the domain would be -∞, -1, u, which stands for union, then -1, +1, u, and then +1, infinity. And that is the domain of that function. Now, when solving a rational equation with fractions, I like to use the least common denominator, which here would be x minus 4, and use that to cancel out. So I'm going to put x minus 4 by the first term, and it cancels the fraction, leaving 12. Then I will put x minus 4 by that 2. That does not cancel. It leaves me 2, and then that x minus 4, which I will distribute. Then I will place the x minus 4 by the third and final term, and the x minus 4 cancels, leaving 14. Now I will distribute and get 2x and -8, bringing everything else down in the equation. Notice I have like terms of 12 minus 8. That gives me 4. Then I will solve for x. So I need to subtract the 4 out, leaving 2x equals 10, and then divide by that 2. That will give me the solution of x equals 5. And the restricted value here would have been 4. Remember, we could not have a 0 denominator. Now in this question, we have imaginary numbers, or the imaginary unit. So what we will need to do is combine like terms. But first, notice the negative is really like a -1 that is distributed to the parenthesis behind it. So negative times negative makes that +9. -1 times I makes that -1i. And I will bring down the other terms. Combine your like terms. So I have 8 plus 9, which is 17, and 6i minus I is 5i. That would be my solution in the a plus bi form. Now we have to use the distributive property to find the product, and that would be -15i squared and +15i. This looks fine as it is, but remember, we were given a definition that I squared is equal to -1. So replace that I squared with a -1 and simplify the first term. The first term ends up being +15 plus 15i. Again, this is in the a plus bi format. Now on this equation, we have to solve it with the square root property, which means we will take the square root of both sides of the equation. When I do that, the square root cancels the exponent 2, just leaving 2x minus 1. And the square root of 121 is 11. But we want a complete solution, so we will include both positive and negative. When you see this, this means you have two different situations. You have 2x minus 1 equals positive 1, and we have 2x minus 1 equals negative 11. Excuse me, that was positive 11 and negative 11. So you will need to solve for x in both of these. So I will add 1, and I have 2x equals 12, and I divide by 2. So x is equal to 6 is one solution. When I do the same process on the second example, 2x will equal negative 10, and x will be negative 5. So those are my two solutions for this equation. Now this next equation, you had a choice of using either completing the square or the quadratic formula. First, we'll look at completing the square for those who would like to use this process. In completing the square, you would take the trinomial and move the constant term 14 over where the 0 is, making it a negative 14. Then here's where the magic happens. You will actually take half of the middle coefficient 12. That means to divide it by 2, making it become a 6. Then you will square that result. So 6 squared is 36. Then you will add this 36 back into both sides of the equation, putting plus 36 plus 36. What this gives us is a perfect square trinomial on the left hand of the equals, and that will factor as x plus 6 quantity squared. On the other side, negative 14 plus, excuse me, the 36 would be 22. To finish solving, I would just take the square root of both sides like in the previous problem. I get x plus 6 equals plus or minus square root of 22, and then I would subtract the 6 on both sides. So x is equal to negative 6 plus or minus square root 22. That implies two answers. Now to solve with the quadratic formula, we would start out with a equals 1 because of the 1x squared, b equals 12 because of the 12x, and c equals 14 because of the original 14 before we moved it with the other process. Now I will substitute in, so negative 12 plus or minus square root of 12 squared minus 4 times 1 times 14 all over 2 times 1. Now when I simplify, that will give me 144 minus 56 under the radical, and when I simplify that, I end up with the square root of 88 under the radical. Now 88 is 4 times 22, and 4 is a perfect square. So we can simplify that as negative 12 plus or minus 2, because these are the repeats, square root 22 over 2. Now divide the 2 into both of those terms, and I end up with negative 6 plus or minus square root 22, the same solution as completing the square. Now on this equation, we must factor. I notice right off the bat that we have a greatest common factor. The greatest common factor is 2x squared. When I factor that out, that becomes x squared minus 100. Now that's great because x squared minus 100 is a difference of two squares, and it will factor again. So I bring all of my factors down and set each one equal to 0 and solve. So when I divide by 2, I have x squared equals 0. Take the square root, x equals 0. You don't need to worry about plus or minus with a 0. Then I take the x plus 10, set that equal to 0, and that gives me negative 10. Then I will take the x minus 10, set that equal to 0, and that gives me positive 10 as my final solution. Now this equation is a radical equation, which means we need to raise both sides of the equation to the exponent of 2. When doing this, we sometimes get extraneous solutions, so we'll have to check our answers. When we raise this to the 2, the radical symbol drops off, and we end up with this equation, but we must move the terms to the same side so that we will be able to factor. So I end up with x squared minus 6x plus 55, which does factor as x minus 11, excuse me, that was a negative 55 there. So that would be minus 11 and x plus 5. When I set each of these factors equal to 0 individually, and I solve, I end up with x equals 11, and of course x will equal negative 5 because that is what will give us the 0 there. Now we must check these. If I take the 11 and substitute into the original equation, I end up with this, which is 66 plus 55, square root of 121 is 11, so that is true. 11 is definitely a solution. But now I must also check the negative 5. So I will substitute the negative 5 into the equation. That will give me negative 30 plus 55, which is the square root of 25. And 5 is not equal to negative 5, so that does not check. Negative 5 is not a solution. Now in this function evaluation problem, we will take the value in the parentheses and substitute that in for the x. So negative 5 times negative 3 plus 1 is the result. That gives me 15 plus 1, which is 16. Final answer. In this function, we have two different pieces. So the x value can only go into one, either the top piece or the bottom piece. Well, in the top piece, it says that x must be less than 1, so that means numbers like 0 and negatives. I don't have that, so I will not use that top part of this function. In the if part of the second, it says x could be 1, so that's the part I use. Substitute the 1 in for the x, and then just simplify. So my final answer is 5. Now on this problem, we have to calculate the slope of a line that goes through this point. Remember, ordered pairs are always x and then y. The first ordered pair I'm going to label 1, and the second ordered pair I'm going to label 2. Then I'm going to use this formula for slope, which you will be given. So the slope would be 8 subtract negative 3 using my y2 and y1. Then I would have negative 7 subtract 2 using my x2 and x1. When I simplify, I notice the double negative becomes a positive in the top. So that will yield 11 over negative 9. Final answer. Now here's another formula problem that we will use, and it's the distance. Again, remember the ordered pairs are always x and then y. I will label them as 1s and 2s and use the distance formula. So the distance here would be 6 subtract 2 squared, and then negative 3 subtract negative 5 squared. Notice that the double negative becomes a positive. And when I work this out, I end up with 16 plus 2 squared, which is 4. Now, the square root of that would be the square root of 20, but remember, 20 will factor like a little factor tree. And notice the numbers that repeat. Whatever number repeats, the perfect square goes in the front, and then the 5 was just by itself, it's a remainder, it goes underneath the radical symbol. So that is my distance in exact radical form. And here's another formula problem. Again, we have x1, y1, x2, y2, and I substitute in using this formula. The x2 is a 7, the x1 is a 5. So 7 plus 5 would give me 12 over 2, which is 6. Then I would substitute in the y values, -1 plus -4. And that's -5 over 2, which does not simplify. Leave that as -5/2. That would be my midpoint. Now we're going to graph using the slope-intercept process. Remember, the number in front of the x is the slope, and that gives us the rise over the run. The number behind the x is my y-intercept, and that's the point that I would start graphing with. So my y-intercept is -2. Plot that point first. Then take your slope, which is 3 over 4. If it's positive, you will move up the number that's in the numerator. So I need to move up 3 units. The bottom number will always move you to the right. So I will go to the right 4 units. Had that top number 3 been negative, I would have moved down. So I'm going to count up 1, 2, 3, and it puts me right here. Then I'm going to count over 1, 2, 3, 4, and it will put my second point right there. And I just sketch the line. That's one of the quickest ways to graph a linear equation. Now in this equation we must graph, and if you recall, the exponent of 3 causes this to look a little bit like an S-curve. We talked about it being like an old country road in class, where it has a twist in the road. One of the best ways to see where this will be is by using some values. I like to use several negative values and then 0 and a couple of positive values. Plug these in one by one into the x. So if I substitute in the -2, that gives me -8 minus 3, which is -11. If I substitute in the -1, it gives me -1 minus 3, which is -4. Substituting in each of the other values will yield -3 for the 0, and then -2 for the 1, and then 5 for the 2. When I plot these points, I have -2, -11, which is way down here. -1, -4 is here. 0, -3 is here. 1, -2 is here. And 2, +5 would go all the way up here. So when you connect the points, you notice what I said about an old country road. There's a twist or an S-curve in the middle of this graph. Now we will go on through and set up this problem in the point slope formula. Remember, it's asking for point slope, so you would not simplify. The slope is the m, so I substitute in a 3 there. The x1 is 5, the y1 is 8, because we were only given one ordered pair. So that will be x minus the 5, and then y minus the 8. Do not simplify, as this is in point slope form already. Now in this equation, we're asked to find a perpendicular line, and we have to start off with the point slope formula. So our x1, y1 will be a 2 and a -2. The slope has to be parallel to this equation. This line has a slope of -3, and parallel means same slope. So we will use a -3 for our slope. Now this is the point slope version, but we have to simplify because the directions said to put it in the slope-intercept form, which means solve for y. So my double negative becomes a positive, and I distribute. It's -3x plus 6. I subtract my 2, and that's -3x plus 4. Final answer. In this equation, we want to subtract two functions. So we will take the terms of the first function, and we will simply subtract the terms given in the second function. Now when subtracting, remember it's like an understood -1 that distributes. So those second set of signs, that's a lot of s's, will change signs. Once I do this, I will go ahead and combine my like terms. So my x terms combines to be negative 5x. My negative 6 and positive 7 would be plus 1. Final answer. Now in this, if you remember, this symbol with a little circle means composition. Composition simply means we are substituting. Whatever function is mentioned second, which is the g, we will take those terms and substitute it into the x of the first function. So instead of f of x is 7x plus 9, it will be 7 times the second function plus 9. Now when we do this, we will distribute, and you get 35x minus 7 plus 9, and that will be 35x plus 2. Final answer. So remember, that little circle means to substitute. Now here we want to find the inverse. Remember, inverse means reverse. So you will actually let the input, the domain, becomes the y, and vice versa. So think of it this way. F of x really is a y value when we solve this. I want to switch these x and y's around. So I end up writing the problem now as x equals negative 7y plus 1. And now I will solve for this new placement of the y. So I'm going to subtract a 1 on both sides. And then I will divide by negative 7. So y is equal to x minus 1 over negative 7. Now this is my inverse. Typically we would replace the y with f inverse. The negative 1, it looks like an exponent, but it really means inverse. And that would be your final answer. Now in this problem, we're going to use the compound interest formula. Pick out the values that you know. The P is the 9,000 because that's always the money that you start with in an investment. The rate is the 5%, but you need to move that decimal 2 places to the left. The word annually will tell us what value to use for N. N stands for the number of compounding periods in a year. So had that been quarterly, we would have used 4. But we have annually, so we will use 1. And then the 12 is the years. Whatever the years would be the T. So I will substitute in 9,000, 1 plus 0.05 divided by the 1 annually. And I normally put my N and T in parentheses because I like to use a calculator. And the calculator needs that second set of parentheses to calculate this properly. The N is 1, and then I multiply by the T, which is 12. I basically just type this into my calculator. I use a TI-30 calculator, and when I type it in, I'll do 9,000, open parentheses, 1, and then a plus sign, 0.05, and then I use a divided by sign for that fraction. I close my parentheses. Then on my calculator, the exponent key looks like a little up arrow. And then I'll open another parenthesis and do 1 multiplied by 12. And then on my calculator, it has an enter equal symbol. When you do that, you should get the answer of $16,162.71, rounded off. Now here we're going to evaluate without using a calculator, so I would basically rewrite this in exponent form. We see that the base is 9, and we don't know what the exponent is equal to, and that is equal to 81. So what exponent is required for 9 to turn into 81? Of course that would be 2, because 9 squared is equal to 81. You could also put this in the calculator, though, to check it using what's called the base change formula. Using your calculator, you would hit the log key and you would type in the full size number, which is in the numerator. then you would divide by log of the base number. After that, go ahead and hit the enter or the equal sign, and that will also give you 2. Now this one says simplify without a calculator, and it is a natural log. Whenever you see the letters L and N, that's natural log. The thing to remember with a natural log is there is an understood base of E there. And we had talked about the inverse property of logs. Anytime you have two bases side by side, they tend to cancel each other out. So that final answer is just the exponent 2. Now in this problem, we want to solve it. One of the easiest ways would be to match the bases on both sides of the equal. Notice the 27, if I divide by 3, that's going to give me 9. If I divide by 3 again, that's going to give me 3. So basically 27 could be rewritten as 3 to the third. When I rewrite this with matching bases, I can cancel the bases and just solve for the exponents. So if I subtract the 1, I get 2x equals 2, divide by the coefficient 2, and my answer is 1. So keep dividing that larger number until you can match up the base. Now here I want to solve this log equation. If you rewrite this in exponent form, the base is 3, the exponent's 2, and that's equal to x minus 2. Many people prefer it rewritten in this base and exponent form to look at it. Now we see that 3 squared is 9, and I simply add the 2 to both sides. X is equal to 11. Now this is the last question that was in your study packet, and we use the addition method to solve the system. You should get an x and a y value as your answer. The numbers will not cancel, so I'm going to multiply everything in the first equation by -8. You may ask me why I'm going to do that. I only do that because I want to cancel out the x term. And I bring over my second equation. Now if I add these straight down, the x terms cancel out. And I end up with 27y equals 162, which if I divide by 27, I would see that y is equal to 6. Now that's only part of my answer because my answer is an ordered pair, and I now know that 6 is the y value. So I'm going to go back into the original equation. I'll just take the first one, but you could use either one. Use the original equation and plug in that y. So I'll have -4 times 6 right there when I'm trying to solve for x. When I do that, I'm going to add my 24 to both sides. X is going to equal to 9. So the x value is 9. Good luck with your final exam studies.